Alright, let's solve some more system of equations with more methods. So we've talked about substitution so far. Now let's discuss the notion of elimination. So let's say we have the line y minus 2x is equal to, let's say 8. And then let's say we have another line. Let me change the color. Let's say we have another line that's let's make this 2y plus 2x is equal to 1. Alright, so we know the method of substitution, right? So what we can do is solve for y on one of the equations and then plug it back in and figure out what our x value is. Now, if you don't know what substitution is, I encourage you to watch the previous videos in order to figure out what substitution is and then come back to elimination. So what we can do, let's do substitution first. So let's solve for y for the first equation. So we're going to get y is equal to 2x plus 8. I'm just adding 2x to both sides. And then we can plug it back into this to this equation right here. So we get 2 times 2x plus 8, because that's what y is, plus 2x is equal to 1. So now we do distribute the 2. So we get 4x plus 16 plus 2x is equal to, is equal to 1, right? So now what we can do is solve for x. So let's go ahead and solve for x. So we get 6x is equal to negative 15, and x is going to be divided by 6, negative 15 over 6. Let's simplify that. Let's divide both by 3. So we get x is negative 5 over 2. Alright, so we have our x value. Now, in order to find the y value, we plug it back in to, we can plug it into this one, right? Because this is already solved for y. So let's plug it back into this equation and get our y value. So y is 2 times the x value plus 8. Alright, so y is 2 times negative 5 over 2 plus 8. So it's just negative 5 because the 2's cancel. Negative 5 plus 8, which comes out to just 3. So we already know our answer. Our answer is just negative, I'm going to write the answer right here. Negative 5 over 2. That was a huge negative sign. Negative 5 over 2, comma 3. And that right there is the point of intersection. So that was a quick way. I went really fast on that, but you should know how to do substitution if you're on elimination right now. So now let's discuss the notion of elimination. So we have our two equations, y minus 2x equals 8, and we have another one that's 2y plus 2x is equal to 1. So what we can do is we can add these equations vertically. So we add the y with the y's, the x's with the x, and the constants. And you notice that if you do that here, the x's are going to cancel. And if the x's cancel, that means we're going to have one equation with one variable. And that's good. If we solve for y, then we just plug it back in to solve for x. So let's go ahead and add these equations vertically. So y plus 2y is just 3y. And then negative 2x plus 2x, well, that cancels. That's what we wanted, so that's good. And then 8 plus 1 is 9. So look at that. Look how fast the y value popped out of this by doing elimination. So we already have the y value. Boom, done. So we have y is 3. Now we can go ahead and solve for x. So we just plug it back in, right? So we know that we know y minus 2x is 8, so let's just plug it back into this equation. So we do 3 minus 2x is 8. Subtract 3 on both sides. This cancels. We get negative 2x is equal to 5, because 8 minus 3 is 5. Divide by negative 2. I'm going to go right here, actually, sorry. Negative 2x is equal to 5. Divide by negative 2 on both sides. So we get x is equal to negative 5 over 2. And look how much easier this was than this whole mess. And obviously we got the same answer of negative 5 over 2, comma 3 by using, in this case, the right method of elimination. So elimination. Hopefully that's how you spell it. Alright, so we just learned the method of elimination of adding or subtracting the two equations in our system in order to cancel one of the variables. Now, if the y had a 2 next to it, and let's say the x didn't have anything, then we could have subtracted these two to cancel the y's and could have solved for x after. So now in the next video, we're going to be doing an example of elimination. So I'll see you guys there.